Greg will be talking. There we go. We get to see the main man in action. So very exciting. And we're going to go into schedule planning for this afternoon. So we don't have a lot of questions from this morning's session. So I'd like to open it up. If there are breakout topics that the group would like to talk about, we can write those down. And we also had the Rolang team, like the folks working on the Rolang coding next door, they had some questions. So do you have a list of questions you want to ask, Tim? Okay, why don't you come on up here?
Sure. So one of the questions we have is like the status of the implementation of what we want to see in Mercury in the end. So we were asking ourselves, oh, can we already run, for example, nodes which speak to each other in the cloud and such stuff? So we would like to know more about that. And actually, what is, like of the Mercury spec as well, what is already included in the version 2.0 at the moment? Like what is already implemented?
Okay. So that's a lot of questions here. So I'll take the first part. So in the .2 node, we have an implementation of the Rolang language via the interpreter. And then we have our P2P communications implementation. But the two are separate. Our focus was to get a Rolang implementation out there for everyone to use that was more robust than the January 31st SDK. So that's what Node.2 brought. With Node.3, it's our intention to try to bring those two together in such a way that the node runs as a daemon in systemd. So the node will always be up. There will be a node API that will expose both the evaluation mode and the REPL mode. We hope to be able to send consensus messages across the network. So Michael Birch and Kent are working on a Scala implementation of consensus. And it is our goal that they're going to work closely with Pavel so they can send messages across the network, and you'll start seeing consensus in action. That's Node 3. We're bleeding a little into the roadmap presentation tomorrow, but Node 4, we hope to have more functions around monitoring and more functions around metrics and the TLS implementation. And then by Node 5, I hope to have a blockchain in a DevNet. So we will be able to see validator bonding, unbonding, no slashing, but we will see a blockchain manifest. So about 60 days to DevNet, and then hopefully testnet 90 days. It's about the July timeframe.
So the short answer is that direct node-to-node communication via anything other than blockchain has been de-scoped, at least with respect to this dev effort. However, I've been talking to DAPHub to see if they will help with the getting a channel or port that's backed by TCP/IP and a channel or port that's backed by some other kind of communications mechanism in a time frame that's a little shorter than after the blockchain implementation. And part of the reason for that is because I think we're at a very, very special point in this whole development process where we're going to have more application developers' eyes on this than at any other time. And so what we want is for people to, whenever they think middleware integration, they just go, hey, why don't we just use the node, right? And not all of those middleware integration efforts are going to require a blockchain. Like sometimes they want to go to another application, right? So we're going to need support for that, and so we want to get that in earlier rather than later. But we're trying to balance all this and make sure that it's sequenced in a way that's supportable, maintainable, sustainable, highest quality.
Yeah, and to speak into Greg's point, all of that work has actually been specified already. So we already have specifications for the pieces that Greg was talking about. What came down to was what needs to come first, what do we need to prioritize so that, and the collective team's opinion was, let's get the blockchain functioning because we need to see Casper in action. We need to see namespace sharding in action. We need to see all these things in action first and foremost, right? That is our priority.
I just want to say I fully support that. That's the right set of priorities, right?
Yeah.
So that I'm not second guessing the team here at all. That is the right set of priorities. I just also know that we got to do the other stuff too.
Yeah, I'm happy to work on the middleware stuff. We can just work it out somehow.
Yeah.
Because I just sort of showed up. Oh, for the people who don't know me, my name's Rick.
You're a DAP Hub.
Yeah. Well, no, I have my own consultancy, but we work very closely with DAP Hub. So.
Well, we can talk
Yeah.
later. Yeah, let's talk. The second part, I want to get to the second part of Tim's question. So the second part of your question was what part of the rolling language is part of the .2 implementation? Is that what I understand? So I'm going to pass that to Kyle and let Kyle answer that.
So we have send and receive, most of the arithmetic. The match implementation is working. You get to use the matcher in all of the receives, including contracts. So I don't know if you see up here, this is a cell contract. I can put a pattern here, and this means that in it is a process variable, and that makes it convenient to send it on a channel again. But you could do something like the following, or like I don't know if you can see right here, like we for at get comma ret. So that means when I receive the string get and return channel from M, I'm also going to grab the state or call it S from the state channel. So like this is a pattern right here, and this only gets invoked if you actually send the string get. So you can use that to do method calls. So this acts in a lot of ways like a JavaScript object.
I just wanted to be a little clearer on the scope of these patterns. These are very simple patterns. That just marks it as a process. It's a take whatever thing you get here and evaluate it to get a process. This is just a string. But we can do patterns like at for underscore from x p. And this will bind the free variable x and the variable p. So if you send me a process of this form, these two free variables will get bound to the components. This is a tremendously powerful pattern matching language that is already implemented. So this becomes a structural type system that in these pattern locations, those are the types of the things that you can get where we're using the structural type there.
Okay, you will always capture P in this case because that will only match if the pattern itself is underscore. But if you have, if this were Y, you can have P here or you can have underscore here. P will only capture if it doesn't mention Y because what are you going to fill in for it? It becomes a process with a hole in it. Now, we may end up having a data type for process with a hole in it, but that's another story. We're not doing that for Mercury. But if you put the underscore here, it will capture anything. So underscore is strictly more powerful than a wildcard. But if like you can use this to verify that somebody sent you some code that matches the correct API. We're going to use this. We're going to use this to do confinement. So someone can send you code, and we will we'll have a confine method that you can run on an arbitrary process variable. You can confine that code, and we'll take the code and we'll rewrite it so that all of the names inside of it become new name, or all of the free names inside of it become newly allocated fresh names. And then you can use the match to pull out the names that we put in there because the sender matched an API, and so you're expecting certain contracts. So you use a matcher to get out the names you're expecting. And then you can invoke code, and you know that it doesn't send it off. It doesn't send it anywhere that you don't control. So the matcher really is pretty cool.
Kyle, do you want to talk about what's coming up next in for the rolling language? A little bit about your backlog?
Sure. Some of the biggest things that I'm working on are polarization for channels, the ability to say, to take a channel and like cut off the ability to receive on it and then send it. and then somebody else can get it and they can send you data, but they can't like pretend to be you. So you since no one else has it and you're the only one that retains the right to listen on it. And we want some syntax to make it easy to declare 2 channels, each of which is the same, but something like this: new x comma y colon IO pair. And so x and y would refer to the same channel, but x would have the ability to x would only have the ability to read, and y would only have the ability to write, or vice versa. I don't know. We'll figure it out. But presumably read, write, because that's the kind of standard way to order them. I'm working on an expansion for the matcher. So right now, so if you, yeah. So I don't think we have width, but anyway. Yeah, there's also no case keyword. So, sorry, A comma B. So you can match lists of specific lengths, but there's no way at the moment to match lists of this length or longer and get a handle on the remainder. Yeah, I'm working on it.
That's what he's just telling you. He's working on it.
So A, B, dot, 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 C, and C gets the remainder, and it will always be a list of length 0 or more. So we're going to put that, similarly, we're going to put that everywhere where we do arity matching. So that you can put that in contract, you can put that in here. Yeah, in 4 patterns.
We're also working on methods, right? Methods is coming, and then
Methods is done.
it's done. It's not shipped, but it's done. That's Kyle for you.
So certain processes at the moment, namely lists, but eventually we'll have more. Like confine will be a method on a process. So if you can do, if the list were, right, if we knew that, oh, sorry. Yeah. Most of this was from another discussion. So if I know that x happens to be bound to this list, I can say x.nth 0, and that will resolve to 1. Well, not from Rolang, but we expect you to be able, there's an API that methods have to follow, and you basically just stuff them in a table, and we do the right thing. So if you go stuff them in the table, then you can add methods. Yes. You would. Yeah, so we might make it so that we can automate that so that you can include in a jar a table of strings and methods, and we verify that the methods have the right types, and we insert them in the table automatically from a jar.
That's for built-in sites too. We had Kent and I.
Just to enrich what Kyle was saying there, if you look in the Rolang interpreter code base, you're looking for a class called runtime, and you'll find that dispatch table right in there. Yeah, it's actually fairly...
I think his question was about defining methods from within Rolang. That is not currently part of the language, but we're considering how to make it part of the language.
Yeah,
So that's still a design decision that hasn't been finalized.
Right, yeah. So, but Kent and I worked out a fairly elaborate design for that. I guess maybe we didn't communicate that. So
The other thing that we aren't planning for having for Mercury is the ability for the environment to contain anything other than Rolang types, Rolang terms. So eventually that's something that we'd like to do, but for Mercury we're only planning to have Rolang terms in the environment, and then you can define methods on them via some kind of foreign function interface, but not quite like the dispatch table. This would be subtly different. It's actually in reduce.scala, the table.
I'm sorry if that was just covering that, but what can you return from the foreign function interface? Can you bring back?
You can return any Rolang term.
Any Rolang, okay. So which means you have a marshalling. And so that means any code.
Yep.
Yeah, anything.
Yeah. In fact, if you have, so as an example, if instead the list were and I evaluated this, so if this were x, then if I have just this term, it has no effect. But if if this is the contents of x, then so it's behaviorally equivalent to p, but p par x dot nth 0 is not behaviorally equivalent to p because it's also going to execute just this send. So one thing that we might do is one thing we could consider is right, where we take the contents of a list and then we turn it into a par instead of a list. So that would be something that would be useful to do.
Hi. So to expand a little bit on that, what Greg was saying, like that it's maybe planned. There's some kind of when a use case is for some kind of middleware that then a node can be used. So I want to ask a little bit on that. Like, could you have a setting, maybe like some IoT devices or something like that, where you want to say something like a private blockchain, so that you can set up your own RChain running there? So is this, would this work with the Mercury release or afterwards? How is the schedule if you want to set up like your own peer-to-peer net, like a small peer-to-peer net, where you want to control the consensus, where you say, okay, I know the nodes, I have here a trust environment?
So,
I mean, first of all, the code's all open source, right? So you can launch a node anywhere, right? It doesn't have to be connected into the main net. So you can always build a little private network of nodes from the get-go. I mean, from the point where you have Mercury. So, but I'm not sure that that's the full extent of your question. I think you're also asking, can I connect external devices into these nodes? And the aim is to be able to have at least some APIs supported, right? So, REST, TCP/IP, a few of the sort of basic ones.
Yeah, just some kind of like proof of authority would be fine. Like I don't need a consensus algorithm if I know this is my testnet, but I still want to have like these very nice peer-to-peer properties where I can say, okay, a node can fail or not, but I know all my nodes are.
Yeah, exactly.
Stuff
so
like that.
That should be doable, but we have, this. I can't make commitments, and I certainly don't want to sign the team up for something that's a death march, right? But that should be doable. Yeah.
Should be doable. Okay.
So even without middleware support directly, you can still interact with the blockchain by having things watch it and then deploy contracts triggered on what they see. So the idea of the middleware is to make writing that code possible in Rolang as system contracts on the node rather than writing it in something else and interacting with it. The reason that we're not prioritizing that is because there's already plenty of stuff to do, and it's already possible to interact with the blockchain in that way. We're working on making it more convenient, but convenience needs to be pushed out a little bit. That's what we're hoping the DAPHub guys and anyone else, Rick, will help with to take some of that weight off of us.
Yeah, sure.
So I heard some people talking about compilation on this event. Currently, Rolling is an interpreted language as far as better. So currently, Rolling is an interpreted language as far as I know by Rosette on the Java virtual machine. So what are the plans for compilation of Rolling, and what is the relation of eventual compilation of the language to the virtual machine execution environment?
So the current plan is that for performance, we will take the Rolang that we can tell, and it's actually not that hard to do when you compile Rolang. You can tell which bits are going to be used as data and which bits are going to be used as code. We will compile the bits that are going to be used as code to run on the Rosette virtual machine. But they will have the same semantics as the interpreter, and you shouldn't be able to tell from the outside which one you're running on.
And this is a nice example of the parametricity of Henry's tuple space, that we can store continuations both in pure Rolang code and RBL and fire off either one depending on whether it's been compiled yet or not.
We do this right now. That's how we do the standard out channels. Is we store basically an integer that we look up in a table that says, "Oh, run this function," instead of So the continuation is a Scala function that we reference via an integer.
Okay. Thank you guys at Tim for having your team come and your friends come and hang out here and pound on Rolang. That's great. Love more of that, and we'd love to hear the feedback. So we don't have a bunch of breakout session topics that came out of this morning's discussions. There's a lot of clarity around what Henry's building and what Pavel's building, and those are more the really rubber meets the road, so we know what we need to do there. So I'm opening it up to all of you. If you have a breakout session topic that you would like to engage on, we can take some suggestions. The alternative is we could have Pavel do his talk on Scala and then yield the rest of the time back to the group to do other kinds of collaboration while you're here. So are there any topics? Or would you like to give Pavel the floor right now?
I just have some questions for Pavel. I didn't ask this morning, but it looks like, at least with respect to Kademlia, all the message exchange is short sequence. It's like call, response, call, response. Yeah, so you could do... So you could do a justification structure, right, where you, inside the message, you have a pointer to a justification, which is a list of messages, right, which justify why this message comes, and that will help you with your out-of-sequence stuff. Because when you get the message, you say, oh, what's the justification for this message? Oh, it was this message I sent from before, right? And then inside those messages, potentially, they also have justifications. Right, and so you can, it's a kind of security feature.
Yeah, that's basic. Okay, so that's basically what you can do. But if we implement the TCP layer, then that problem disappears completely, right? Because I send a message and I expect a message back, and that's guaranteed by TCP.
Yeah, but it's not. This is a higher level security property because it can go. It's not just. Right, I can have a list of justifications, right?
Okay.
You see what I'm saying?
Yeah.
And then that can cover a wide range of, I mean, maybe in this case it's overkill.
It might be something that we can consider.
Yeah.
Yeah, makes sense.
It's actually, and we've got a Scala implementation of this that's been used in production, so.
Okay, pretty cool.
So TCP solves the out-of-order problem for a single pair of connecting nodes, but if you send a message and it comes around, you don't know if this guy has seen this message you sent unless the justifications are around. So TCP kind of solves it, but
I'm just saying that we don't have this sort of communications yet, right? The out of sequence that we see is basically where we emulate TCP using UDP.
Yeah.
That's where. But if we have something like that, then yeah, definitely.
So the justifications will solve this thing too. So it solves more than one problem.
Yep.
This will be fairly advanced Scala.
That's what I thought.
Put this on your necklace or on a lanyard.
I can put here. Sorry. 1, 2, 1, 2, 1, 2. Okay. Okay, so you don't have to stay. Maybe I can just later on, we can have a chat. I have basically like a few questions. I will show you something and want to know what you think about it. But you don't have to stay here. Like.
I want to stay, but I have to leave at 2 to go pick up my wife from the airport.
Okay, I'm just saying that the questions that I have at the end, but we can still deal with that during dinner or whatever.
Yeah, exactly. Let's just make sure we do that.
Ugh. Almost ready. I'm looking for almost ready. There we are. Oh. God damn it. All right. All right, so basically the idea behind this talk is communication is written in this sort of tagless final way, which, is that mine? I don't think so. Okay. Which we try to make it as a selling point of how we could actually develop software in RChain, especially in other modules where I don't have control. But I think that there's like tons of benefits of how we can do it, and I'll just try to sell it here. So there will be some code on slides. After that, I will jump into Emacs because I didn't have time, basically, to finish all the slides. But we should be fine. So I created a little application here that I want to show you guys. So that application, if you run it, it's a very simple application that does very little, but it's complex enough for the demo purposes. Oh, and it doesn't compile. Yay! That came prepared. I know. Oh wait, no, it's actually wrong repo. So we should be fine. Come on, come on. Compile. All right, now run it. Do you guys see it, or you want a font bigger? All right, so the idea here is we have a little REPL here where you have ability to create users and send them over to some server. So the way to create a user, you just provide your first name, last name, and age. And there's there's a REPL, so you have some. Well, it doesn't work right now, for whatever reason. But you can send those at some point. You provide something that doesn't make sense, and the program will execute with an error, like for example, unparsable line exception. So this is the idea behind the program. So we collect data, we parse that data, we send it over the network. The server receives it, gives it an information back, and then we loop that REPL and continue. So that's the demo. And that's the first approach how we could have implemented. So here are some domain classes that we are using. So there's an error. This is like pretty straightforward. So there's an error type. There's an error type. There's a configuration for our server where it lives. And there's a concept of terminal. This is sort of like our state, because every time we will put something into the REPL, we'll keep history of what we put into it so that we can have a completion and stuff like that. And also this console thing, it's effectual. It should be closed over task, but for simplicity reasons, I just left it as it is. So that's just a slide about the domain. And also we have our user class. So it takes a first name, last name, creation date, age, and Boolean flag, whether it's active, yes or no. And we have this ability to send that user over protobuf or whatever with this add user message. So that's pretty straightforward. And this is how our REPL could look like. So we could, from the state monad, we could get the terminal. We could read the line from the terminal. Then we could parse that line, having that, it would just give us a first name, last name, and age. Having that, we would collect the current timestamp, create a user with all the arguments that are needed to create a user, send that message, and if we get the result back from the server, we would just print it out. And at the very end, we would update the completer with our line. So the user inserted the line over here. So we update our completer here so that the next time that the REPL is being used, that line is available for completion. So it looks pretty much straightforward, right? No magic. You can run that REPL in forever, and it will work. So if we look at all the like individual functions that are listed here in this for comprehension, they will be straightforward as well to sort of reason about. So we have, and obviously we want to be FP, we want to be as close to purely functional programming as possible for testability and correctness and all that magical unicorn stuff. So now system current time meal is effectful, so we close it over monex task over here, pretty straightforward method. There's a host and port methods which will give you a host and port from the configuration, and they are closed over reader monad. So that is pretty straightforward as well. There's a method create user. Now this method returns an either type because there's a little logic here. Like if you're below 18, we cannot really create a user for you. If you're grown up, then we'll create a user for you. So that error message is returned as within the either type. And send message, I didn't have time to implement it, so we emulate protobuf calls here, whatever. But we can imagine that we need this sort of two capabilities here. We need to read configuration, like we want to know the host and port, but we also want to have, we will be doing something effectful, like sending a message over the network. That's why we close that over reader T of task. And yeah, the method probably would be a little bit more complicated, but not that much. The parse line just parse the line, but there might be an error because there might be some issues with that line, so that the return type one more time is closed over either of error or the stuff that we are expecting. And update completer, like the code isn't really that important here. What's more important is the fact that we are using a state monad. So we have a terminal as a state, and we modify it, we do some modification to it, and that's how the update completer method works. It just uses the effect is closed over state monad. So yeah, so now we can use it. Can we? Well, unfortunately we can't, because monads do not compose, right? And now you have to provide this little type here that will accumulate all the effects. So you need to have ability to reason about your state, about your errors, about your configuration, and it's about some code that is effectful that you have to close over a value. So you build this huge effect built on top of the monad transformer. So it's state T of either T of reader T of task. Now, if that seems horrible, let's see how our for comprehension will look like in Scala. And this is it, right? Sorry. Yeah.
Oh, and I was going to point out that like the order that you compose those changes the,
Yes, the order
nature
the
of
composers changes everything. But I don't want to go deep into that. So let's stay here. So that's, yeah, so this is it. And yeah, it's like if, yeah, so much clearer, right? And if you try, now imagine you try to sell FP to some developer, you try to sell them the idea and you show them this, right? I know what you're thinking. I mean, learning about FP is learning about functional composition and all that stuff and everything else, right? But anyway, in Scala it looks ridiculous. There's an old joke that teaching FP in Scala is 10% teaching FP and 90% apologizing, and that's basically what it is. But my question, so I try to make a point here in this presentation that we can actually handle it a little bit in Scala, and it makes so the things that we would like to deal with are maintainability, readability, and testability. Because the code that we have right now is not maintainable, not readable, and not testable at this point. And we want to also be as fast as possible because, unfortunately, the way that the monad transformers are being dealt on the JVMs, they are basically slow. And they are slow for two reasons. Tim pointed me out to a very cool podcast with John DeGoss where he goes specifically into details of why that is. But basically, in general terms, that there is a problem of building those objects all together just so you can then flat map them or bind them. And there's also problems on how the JVM calls are being made if the underlying type is unknown. So we would like to, our final effect, our final type should be as close to task as possible as we can. But with monad transformers, this is not doable. So here comes the MTL style. So, yeah, that slide should be, yeah, so but before we go to MTL, I can just show you that actually, even though that code was horrible, the for comprehension, the underlying, like when we actually use it at the end of the world, the main method is pretty straightforward. We create some stuff which is effectful, and then we have our REPL here we call forever, we'll just loop it, and at the end of the day we run it with some initial state and with some configuration, and we call unsafe run sync, which will just run the task for us. So from the main perspective, that's pretty cool. But we would like to deal with the implementation stuff. So let's go back to that method. Actually, So let's go back to that method over here, like create a user. What's the problem with that method? The problem with that method is that we are making a decision up front for people who will call our method. We are saying it's going to be an either type. But then later on, they have to plug it in to our state T of either T of reader T of task, and they are in pain. Wouldn't it be nice if we could, so instead of just returning an either the error or user, we could create a method that we would let the user to decide of what the f is going to be. So we would say, create a user, and I'm going to give you an user, but we also would like to manifest that there might be errors in it. But the general idea behind this encoding, syntax of this method is that the user makes the decision of what the final type is going to be. But we still need to have, like, we could implement part of it, right? We could make our f applicative. Then if the age is all right, then we create that user and we just call pure, so point on it, and we lifted that into f. So we are fine here. But the problem is, well, what happens if I have actually an error? How can I close an error over that final f that we're supposed to return? With this semantics, we cannot really do that. But there's a type class called Applicative Error, which has this very cool method called rise in error. So it's saying, if you have an instance of this type class for your f, and you have an error, I will give you instance of f of a, of that f, for that error. How? It depends what your f is, right? Because here, that f can be anything. It could be either t, it could be something else. But if we make a constraint that our f is constrained by applicative error, so this error handler here, there's a little type ls here, so error handler is just applicative error of the error. So having this we now have ability to call method RiseError with the error as a E here. So now we can just say, whenever there's an error, raise an error, we provide the error of the type the error, and that's it. As magically we have ability to lift our error into our F. How that's being done, we don't know. It sort of depends, right, of the underlying F, but that's for the user, for the caller to decide. You want create user to return the user value closed over either? Fine, as long as there's an instance for applicative error for either. And there is one, it already exists, right? So this becomes much cleaner. And we could go through every single method within our application. Same applies for reader. So here we are very concrete. We are deciding that you're going to get a configuration, but we are deciding for the user how that information is going to be passed to him. We're saying it's going to be passed through reader. But one more time, we would like to have something different. We would like to say how the configuration stuff will be handled. Well, this should be deleted. Will be handled over some F, but you decide what that F is. And one more time, there is a type class for it. It's unfortunately not included in CATS. The Edmund, who was supposed to provide CATS MTL project, resigned from type level, leaving the project not really, there's nobody, I think, working on it right now. So bunch of the stuff, at some point I will jump into the code, you will see a bunch of boilerplate that's only there because I had to recreate things that should be in CATS from the day one, but they don't exist. So one of them is actually monad reader. So important thing is this little method ask. It looks like reader, right? Because it has the same capability. It's saying, I will give you an f of s, where s is that configuration thing, as long as you provide me an instance of that monad reader. So now our method can look like this. We will say config reader is monad reader of f, and here we have a nice method that will just give us an instance of this. So now we will do what we did before. We will call asks. That gives us a configuration here, server port. So that difference, the main difference between this method and what we've seen before is that previously we were explicitly calling reader. We're explicitly calling a very concrete type, which has this capability of giving us that configuration so we can do with that something with that configuration. Here, for example, take the server and take the host out of it. But with this encoding, we are basically saying we don't care what that f is going to be. It might be a reader, because there is an instance for monad reader that reader gives us, the reader t. But it doesn't have to be. It can be anything else. As long as you provide me an instance of it, I'm fine. And I will give you ability to reason about whatever you want to do. I will just give you that configuration for you. But one more time, we don't really care what that f is going to be. When we are writing this function, the user has to decide, and he is in control at this point. Because he's saying, I'm going to use your method with this type, whatever that type is, and we are saying, fine, you can call us with anything that you want, any higher kind of type at this point, as long as it follows those constraints. And yeah, there might be a question like how would we deal with this stuff? So we have current time method, which was doing some effectful computation here, just giving us a current system time. What could we do about that if you would like to close over some f where we don't know what that f is? And there's a nice type class that you could use. It's called capture. It has different names. Different people use different names. I think CATS effect call it eval or something. Maybe sync. I don't remember. But the idea here is that you can close any effectful computation over some f. And one more time, what that f is, we don't know. It might be a task. That f might be a task, but it might be something different. As long as we provide an instance of it, we're good. So now,
Quick question.
Yep.
Am I right that with capture, the by name parameter, the lazy parameter, is really the important part of capturing? The fact that you're not evaluating that?
Oh, yeah. So this point over here, right? Like if you call me with something that's effectful, like for example, system.currentTimeMills, it will not evaluate. This is by name. This is lazy. This is like Haskell, right? So it will postpone until this is actually being used. So this is like a call by name, lazy evaluate parameter. And same thing applies for, and I just want to quickly, I know there's a lot of slides, I'm aware of it, so I want to quickly skip through it. So there's the same principle applies for state. So there's, one more time, we have this update completer, which just deals with state. One more time, we don't want to decide by the user it has to be a state monad. We want to say it can be anything, but we will constrain it by yet another type class called monad state. And if you look closely at the methods defined on monad state, they reflect there's a strong correspondence between this and the methods that you actually have on a state monad, because the idea is basically the same principle. I want to deal with state. I want to have ability to reason about my state, which is changing over the evaluation of my calculations. So one more time, we can have this function being implemented, and one more time, we have ability to modify our state, and we're good, but we are not deciding what the f is going to be. So this is the same REPL written in the MTL style. So right now, all those different functions here require different capabilities. So like current time needed capture, or send message needed monad reader, or update completer needed monad state. So when we call all of them together, we need to provide an F that will collect all those capabilities. And that's what we're doing here. We're saying whoever calls REPL needs to provide those capabilities. They needs to provide a type that will have all those capabilities in order to REPL to work. Now, the easiest type that you can provide is this. We can still run our software using monad transformer, because that big, huge monad transformer, state T of either T of reader T of task, it contains all the instances that are needed. Either T implements applicative error. State T implements monad state. Reader T implements a monad reader. And there's an instance that I wrote for task. So still, so now you have this REPL, which is still unaware, completely unaware of what type it's going to be used with, but you're constraining that type with all the capabilities that are needed. And you can run it with our monad transformer. So you might be asking me, okay, so what do we gain here? Do we gain performance? No, because we're still using monad transformers. Do we gain testability? Well, not really, because if I would like to write for example, I want to write a test for this. I want to say, like, for example, this timestamp over here is being used for create user method, and that timestamp becomes an element of the user. That's part of the structure. So that's, for example, I would like to write a test that I would say, like, if the current time is 10, then the 10 will be part of the user that is being created. I cannot still really do that, because underneath that current time, it's closed over capture, but it's still calling that underlying system current times mill. So we don't gain testability here, but what we do gain is a little bit of more cleaner code especially when we write those functions, and when we put all those calls together, I would argue it's definitely more readable. But the question would be, can we go further? And and that's where I have to jump here. So stay with me. So what we could actually do, and this is something called tagless final. So I have two things which are effectful, which are not allowing me to test my REPL. One thing is console, because the console, whatever the class name is, console, sorry, MTL style. The console reader, this guy, is effectful. So like if I try to run it within my test, it will just run typical methods on the console. It's effective for computation, and also that time thingy is also effectful. So now the question is, what can we do about it? And the idea is here, it's sometimes referred to as tagless final, is that the fact that that capability, for example, printing stuff to a console or reading stuff from a console, we can close it over type class one more time. So now I'm saying this is something that I've created specifically for this project, because monad reader, monad state, those are the type classes that you would normally use, like those are more common, more general. But here, for my specific problem that I have, I need to have a capability of reading stuff and writing stuff to a console, so that I can provide this type class with all the methods that are needed, so read line and print line, and then I could create an instance for it. And this is what I'm doing. This is what I'm doing over here. So let me show you. So I provide a dayline console IO, which take console reader as an argument, and provide instance for console IO type class, so the type class that I created, which will just reuse this stuff. The same applies for time. So I could create a type class which is called time, which only at this point have this one single method, which will give me current time millis closed over some f. I don't really care what that f is. And I can, for example, create an instance of this type class, which will return time closed over task, and we can call it instance system time. So what really changed in our implementation? So the previous program stays pretty much the same. The only thing different is, let me just skip to, yeah, whatever. One second, came up prepared. Fix that. There we go. So you guys see it? The font? Yeah, all right. So the only difference within the program that we've seen before and what we have right now is that REPL is above this method. It stays the same. So it still is, maybe I should just show it to you guys. So that REPL, where are you? Here. So that REPL is still the same. It still is completely unaware of what f is, but got two additional constraints. One is console IO, and one is time. So again, we're saying you can call me whatever you want, as long as you have instances for those two type classes. And then, if we look how that's actually being used, so main method over here, the only difference is that I provide those two instances over here, and now this whole program can run. Now, the question might be, so what did we gain? Well, actually, right now, we gained that testability that we wanted to have. Because if we look at the specification, what I could do is, within my tests, I could create a test, a final effect for my test. So the only difference here is, just within tests, it's still state t of either t of reader t, but no longer task. It's eval. Eval is like, it's effectively doing the computation at the given moment. So for tests, we are closer to like, so if you run the call, it will immediately evaluate. So, and then I could provide instances of console IO and time, which are stops. So let me show you. Actually, I think I have stops. There we go. So for example, just for tests, console IO can have constant read line. So whenever you call read line, it will always give you that line that you provided as an argument. But whenever you call print line, it will do nothing, but it will store the lines that you tried to print it out to some mutable list at this point. Not mutable, but the list that changes its value by referencing a new list. So then, and the same can go with for time, right? I can create an instance for time, which will just always return that TS that I told it so. So now, when we're writing our tests, the whole description is basically here, but I can reason exactly what the timestamp's going to be, and I can also reason about, like for example, about my console output, that it will have this string and it will have that string. So now, if we look at closely at what that is giving us at this point, is that it pulled all the details to the boundaries of our application. Like if you guys familiar with hexagonal architecture or clean architecture, whatever, this is exactly what it is. How I push stuff to the console is a detail at this given moment. How I read timestamp is a detail. Same would go for sending messages. Like the fact that I'm using gRPC is a detail that I shouldn't be really concerned when I'm writing a business logic. Now, so I don't know, is that a selling point or? Yeah.
I mean, classically, you're just saying separating interface from implementation, right?
Yeah, it's basically what that is.
You could generate an AST of case classes that just
I
have all of the
will-
function calls.
Yeah, so
you know.
I will argue you can write good software in every language and every paradigm. The only question is how much of cognitive power you later on need to sustain the nice level of robustness in it. How much the compiler and the paradigm will help you to not allow crappy code just slipping into your code base, and how much you will have to rely on code review to go through every pull request because maybe somebody will just provide something which is not cool for your design. But yeah, this is basically what it is. It separates that sort of implementation from the interface.
So one of the things that you can do is you can say, well, I'm using reader, but I don't need local, and I don't need this and that.
Yep.
And so you can say, okay, well, I can actually create a type class that's tighter.
Yes, you can specify a tighter type class that only provides those methods which are needed. Yeah, there still is a little bit of problem, and the problem lives in the matter that if we look how the encodings are within the functions that we use, so all those functions like REPL and all other functions that we are using becomes not much cleaner, but at the end of the day, we are still using this huge monad transformer. Now the question would be, what could we do about it? And the answer is, well, we could actually flatten that type, because we don't have to We don't have to use reader_t to provide an instance of monad reader. We can imagine there will be some place where that configuration is stored. That instance of monad reader will have an reference to that configuration, and whenever you ask for it, you will give it to him. And that's what we're going to do here. So, and I'm closely to finishing this, so stay with me. I know there's a lot of code. I'm pretty aware of it. So what I did here is you can already see that this type is a little bit tinier. I removed the reader_t part. OK, so you might be saying, well, shouldn't compiler complain that there is no instance for monad reader? Well, it should, but I've also provided. So let me show you. So I've added 2 classes, and this one is actually stolen from remotely. So it's a class called TaskRef, and TaskRef will hold atomic reference. So whenever you do modifications to it, it will state monad at this point. It has a modify, it has a write, it has a read. So just based on that, we could actually provide instances for monad state and monad reader. Important thing is that when we create an instance of TaskRef, when we create it with some initial value, what we get back is not really TaskRef, it's task over class TaskRef. So let's return a recipe for this method to run at the end of the world. Because what we want to do in functional programming, we want to build this huge big function which is called at the end of the day. So there is no, at first when you look at it, you might be thinking, oh, imperative code. But it's not really, because it's still every call is closed over task. It just postpones the effects that it holds. Like, for example, modifying the internal value under atomic reference. Once we have that, we can go to monad reader. Yeah.
So you wrap the task ref in a task, and by nature the task is supposed to be like for the asynchronous computation. Could we do the same thing like we did when we moved from the monad transformer to MTL, that you wrap it in the like arbitrary f that
like
has
capture? Yeah, you could.
or
Yeah, you
eval
could,
or
but I'm only using this at the end of the world where I actually want to use task. So I'm not really, I'm specifying the type very, very explicitly that's going to be task, because this is what I want to use in main method, not anywhere else.
But if all your calls in the main method will be synchronous, to run a task, you still need execution context, which would be like unnecessary if all the calls are synchronous. Right? To call unsafe run async, you
Yes,
need an
correct.
execution context.
That is correct.
Okay.
So that's I promise we're reaching the end of this. So there is an instance for monad reader for, and we that local don't really like, we really care about this ask method here. But the thing is, we provide an instance for monad reader for task and some arbitrary R. In our case, that R will be the config class, as long as you will give us task reference to that instance. So when you instantiate it, you need to provide the value, the configuration closed over that task ref. So now if we go back to our example here, you will see that we no longer, previously when that was a huge monad transformer stack, we had to run it with configuration. Right now this configuration, the monad reader is provided here using that task ref monad reader. So config becomes a task of task ref that's available for us, closed over atomic reference, and we provide this instance closed over that task ref. And we can do the same thing, and I will not go into details right now, but we can do the same thing for reader. For state monad. So we can provide a monad state of task of terminal with the, let me show you this, it's over here, initial state. So initial state will be closed over task ref, and we can provide an instance of monad state with that task ref. Now the question is, one more time, what does it give us? Well, in theory at least, we ended up in having a type which is very, very flattened. It's really close to a T. Like, we still have a monad transformer because we still have either T of task, but we are down with 2 layers of monad transformers. So at least in theory, this should be more performant. Question?
Task includes arrays error, so you could actually throw that one out too.
No, well, not yet, not exactly, because the problem is that the race error gives you the f of throwable, and the applicative error requires f of a. So you could cheat, and I was hoping to cheat, but I was hoping I will have like 2 more hours to prepare this presentation. You could cheat a little bit, but this is something that you wouldn't like to use in production. However, that was my selling point for Greg, because I really would like to convince him that we should use Scala Z, because within Scala Z8, the final I/O is parameterized by 2 types. One is the A, and the other is the error type. So you can actually write an applicative error for task, and your final effect will be just I/O. But yeah, we could cheat. However, I have benchmarks for you guys, and they are promising. So, well, not in this comment. Yep, give me a second. There we go. All right. So, and this is important. Like, this is the whole beauty that we're gonna get from this tagless final approach. I have a program here written for those. That's not needed. Written for those benchmarks, and program is fairly easy. We're using the functions that we created before. So we're reading host from configuration, and so do we read port. And now, if the host is local host, we will raise an error, host not allowed, with our local host. If the host was something different, then we will just return it as a host, port, and return it as a value server here. And then within terminal state, we will just store into history that server, that value that was provided. This is very straightforward program, right? Does it make sense, this program so far? And check this out. This is written in that tagless final way of writing software. So I'm not saying what those f's going to be. I'm saying it just needs to have ability to handle error. It needs to have ability to read configuration, and it needs to have ability to manage state. And then we have 3 different benchmarks. I will tell you in a minute why 3. Maybe I will just show you the first 2 at the beginning. So the first benchmark is using monad transformer stack. And that's the beauty of it, that I can, for both of those 2 benchmarks, I can reuse the same program. And if I'm not happy with performance, then I can actually do something about it. But I'm doing something about it, not trying to find little places within my code. I can reason about it at the boundaries of my program, where the type classes are defined. So my program will be called with, let me just show you those effects. You still see it? So we have here the monad transformer, which is state t, either t, reader t of task, which provides all the capabilities that our program needed. And we can run it with initial state. We can then take value from either. We can run it with configuration, and at the end we'll get task which we run. And also we have an equivalent program which is using flatten effect. And flatten effect here on line 63 is just that either t of task, and there are instances for monad reader and for monad state which are implemented with task ref. So the stuff that we've seen before. And I could run it. Just to prove that it works. But I actually have the values over here. So how many of you guys are familiar with GMH output? OK. So GMH will run benchmark for us. We'll do the warm-up for the JVM. We'll do all the things that you would probably break. It will do it for you correctly. And you can see that here, the monad transformer stack, when it was in mode throughput, was able to do 0.367 operations per microsecond, while this exactly same program that was using this flatten type could actually do it 3 times fast. Now, there is one more benchmark here, which is called RWS and either T. I can actually show you guys this. So this is something that Tim pointed out. There's a very weird class which is called index reader writer state T, and you look at it and you might be like, what the hell? And then you read comment and it's just saying, in other words, it's a reader T and writer T and state T. And at this point, OK, so why not to use them all together? Well, as you can see from, so the final benchmark that we have, the last benchmark that we have, is calling that program with this effect. So this effect is very similar to the effect of flatten effect. Okay, let me show you that effect. So that's either T of that indexed reader writer state T. So that is this huge class that collects everything all together. And apparently, this is magnitude as fast as the previous approach that we had, because it sort of accumulates all that stuff from reader and state. There is obviously a scenario that maybe I don't know how to write benchmarks, and maybe I said there's some problems. But this isn't really the issue here. The main issue and the main selling point I'm trying to achieve, well, is that the program, if you look at those benchmarks, the program is exactly the same. We can write programs which are readable, which are testable, and if we have performance issues, we can deal with them globally. It's not that we're going to choose state T and either T, and at some point we will realize, holy crap, this is slow, and now we have to redo all the functions called in our projects. We could do it at the end of the world in the main method. And if atomic, let's say that reader-writer state class is slow also. Maybe there's other approaches. Like there's atomic queue, right, that we could use. There are a bunch of other ways to approach the performance problems, because there is no like a silver bullet for it, right? But the issue here is that we can do it regardless of how complex our program is. So this is how really quickly. This is how
I think also if you have a
yeah, I'm sorry.
I think also if you have an optimization pipeline, this bundles it all up into a package that that optimization pipeline can act on before you run it.
Yeah. Yeah.
So there's even more opportunity for fixing problems after you've built the program.
Correct. So this is how communication works right now. The communications when I joined it was fully imperative, but I could provide that boundary really clearly between the FP code and the imperative code by closing everything that was imperative into capture. That didn't give me any testability whatsoever, but at the beginning it gave me a very clean line where I want to be and when the rest of the code is. And what I've been doing for the past 2 months was just slowly pushing that boundary, removing the imperative stuff, until I reach a point where we have an ability to test our protocol. Like we can reason about what should happen within within Node. If you're connecting to a node that you haven't seen before, the first thing that you need to do is you have to send an encryption handshake message with a public key. And then we stop the communication effect. We provide a communication type instance of communication type class that will remember every call that was being made to it. So then when we call connect method, we can assert a few things. Well, first of all, that there was a request actually on our list of requests, so somebody actually called round trip method, and that it was actually an encryption handshake message, and that message was holding a public key, and that public key is actually what we're hoping it to be. And we can write all the tests for all the protocol that we have without running peer-to-peer network. Well, by just basically putting the details away from our unit tests. And my plan for the next... Yeah.
It should be on. I think it's on now. Just took a moment to go green. So for the implementations of for your instances, theoretically you could also like build up case classes, and you could have an entire AST of all of your effectful code that then you could go and inspect and look at. Right?
Oh yeah, if I like pain, yes.
Well, but it's just like an interesting, like maybe there's some way to capture optimization by like then going through and
oh yeah, I agree.
Applying
so
optimizations to your AST.
Yes, I agree. Like you could for every call you could create a structure,
right.
And then you could reason about the underlying the structure that was finally being built.
Right.
So you can reason which elements of the code were being called first and which order and whatnot.
I mean, it's wacky. It's just to sort of goes to show that there's all sorts of things you can do.
It gives you this flexibility.
Right.
So I'm trying to sell a few points. The methods will be cleaner to read because if you like the boilerplate, I mean, if you guys are previous Java developers like me, you are pretty familiar with boilerplate, right? But I would reason that maybe this is not the right way to write software. So cleaner methods, maintainable methods, testability, and an ability to reason about the code in different ways, especially in terms of performance and tests. And that's all I had to say. I will just add that I will try to spread through RChain this approach. So be ready for me nagging you in pull requests. This should be MTL. This should be tagless final. Yeah, that's all I have for now. Thank you, guys. Yeah, there's so all those within COM right now. So we have, well, there we go. All those effects are right now defined within COM because those are COM specific. But as it turns out, right now the metrics API needs to be defined, like it's going to be used in storage. So this effect will go into shared library, and so that will be used because. That's really quickly. The node Scala is the place which puts all that stuff together. There are still things which are imperative, and they are being called imperative. And at some point, I hope they will disappear, and they will just be closed over task. But essentially, if we have a thing like runtime, runtime could return an effect of f that would hold the metrics API, which you could use. So that's slowly spreading through the rest of the code. Hopefully, by the end of the Mercury, it will spread like a virus. Yeah. All right. Thank you very much, guys.
Wait, are there no more questions?
Oh yeah. If there's questions, I can. Yeah. So Tim, you were asking what are the performance benefits, right? So we can clearly see that. We can flatten that. It will. The one thing I want to do is right now, maybe after this session, is that as Kyle said, I can provide a sort of wacky, weirdy applicative error instance just for task. It's doable. It's going to be with. It will just task, right?
Just write our own task with parametric in the error. Yeah.
Or that, yeah, or use Scala Z8, and see how that will perform, whether this will perform better, yes or no. And also the question is, do we really have to, for example, close the value like configuration or state close within a task graph? Like if it's going to be used in one place, maybe it's worth also to have it like access in that particular place. But
the config ref you can probably not make atomic because it's just read only.
Yeah, it's just while the state is probably better.
Yeah.
Yeah, and also task graph was stolen from a very old version of Remotely. Scala Z8 right now has its own version. Monix has its own version, so I haven't tested it with those implementations. Maybe they are more performant. But one more time, that's the optimization that we can do later on. If there are no questions, I'm done. So what now?
So now we are at 2:30. Unless there's anything else somebody wants to bring up as something to use this time for, you're welcome to. This is your time and space, and you're welcome to it. If that's not something that everyone or even a small group wants to do, we're done.
That was great. I love reading your code.
Strawman refactor of storage, though, and it's something like 40 minutes.
Really? Nice.
But the problem is still
the parameter.
store.
So you push that parameter up to the definition now?
Just that. Well, when you think about what a store is, does a store really? A store is like not a thing. It's like a data type that we want to pass around.
Yeah.
So you put it in a reader.
Oh yeah.
Then you could like wrap that in some kind of monad store that is a reader, so that we're passing an environment around if we wanted to do it that way, right? So then when you instantiate the thing, you just pass it in the store. Like when you do the run, you pass it in the store, right?
Yeah.
But I mean, at the same time, too, it's just.
Well, if modifications on store are mutating its internal effects, then.
Well, it's like the old, reader T, IO ref, or as we call it, task ref. Right? It's the same vibe, right?
Well,
it's like a mutable variable in a reader.
If you return that as a reader T of task, then fine, right? If you close that store over task, then we're good. But if you're just passing it as a reference, which you mutate, then no.
Oh, so you don't like to have mutable things in your reader environment.
If they are close over task, then I'm fine.
You're fine with it. You just don't. You just spiritually are opposed to having mutable.
Not spiritually. It's just you will end up in a code that if you call it, it modifies it, and if you call it one more time, it will behave differently, because that underlying store is modified already.
Yeah.
But if it's close over task, you call it twice, it will give you the same result.
Got you. Got you. No, very good point. Very good point. I have to stay pure. You gotta stay pure.
Yep.
When in a language with unrestricted side effects, does one just use unrestricted side effects?
That's a philosophical question.
But I'm quite surprised that